What if I told you there's something out there so impossibly large that our entire solar system, every planet, every moon, every asteroid could disappear inside it without a trace? Not a galaxy, not a nebula, a single object. And it's hungry. This is Phoenix A star, the universe's most terrifying ultra-massive black hole. And what you're about to discover will fundamentally change how you see the cosmos. Right now, we're boarding Nova 3, a spacecraft capable of light speed. Our destination, a monster lurking 5.8 billion light-years from Earth. At 300,000 kilometers per second, we zip past the Moon in 1.3 seconds. Mars, 12 minutes. Pluto becomes a memory in just 5 hours. But then, reality hits like a sledgehammer. Beyond our solar system, even light speed becomes pathetically slow. 4 years to reach our nearest stellar neighbor, Proxima Centauri, 100,000 years to cross the Milky Way, and Phoenix A star, we'd need to fly for half the age of the universe itself, 5.8 billion years of uninterrupted travel at the fastest speed physically possible. Think about that. During our journey, Earth's oceans would completely evaporate. Our sun would die. Entire civilizations could rise and fall, and we still wouldn't be there yet. Then finally, through the cosmic void, something emerges. A structure so massive it defies comprehension, and at its core, waiting in absolute darkness, is the apex predator of the universe. Most galaxy clusters are cosmic graveyards, cold, quiet, dead. But the Phoenix cluster earned its name for a reason. Like the mythical bird reborn from ashes, this cluster pulses with violent, chaotic life. Torrents of superheated gas spiral inward, igniting thousands of stars every single year. That's hundreds of times more stellar bursts than our entire galaxy produces. But all this creation serves only one purpose: feeding the destroyer at the center. Phoenix A star isn't just supermassive. That word doesn't even begin to cover it. This is an ultra-massive black hole, a classification so extreme, so beyond normal comprehension, that astronomers had to invent a new category just to describe it. Let's talk about Sagittarius A star, the black hole at the heart of our Milky Way, 4 million times the mass of our sun. To us, it seems unimaginably large, but Phoenix A star is 100 billion times the mass of the sun. If you place them side by side, Sagittarius A star would look like a single grain of sand next to Mount Everest. 100 billion solar masses. Try to picture that. Take every single star in the Milky Way, 200 billion of them. Add every planet, every asteroid, every gas cloud, every speck of cosmic dust. Phoenix A star weighs as much as all of that combined. One object, one entity. The mass of an entire galaxy compressed into a single point of infinite density. Now imagine we could somehow transport Phoenix A star and drop it where our sun currently sits. The event horizon, that invisible boundary beyond which nothing, not even light, can escape, would instantly consume Mercury. Venus would vanish. Earth would be swallowed whole before anyone could even scream. But it wouldn't stop. Mars obliterated. Jupiter devoured, Saturn gone, Neptune and Pluto wouldn't even reach the outer edge, and Voyager 1, humanity's most distant spacecraft after 45 years of travel, would still be trapped deep within the darkness. The diameter of this monster? 590 billion kilometers. That's not an object, that's a wound in the fabric of reality itself. Let me put this in perspective using the only thing in the universe that nothing can outrun: light itself. Light moves at 300,000 kilometers per second. At that speed, you could circle planet Earth 7.5 times in 1 second. Now imagine a spacecraft skimming along the event horizon of Phoenix A star at light speed. How long would it take to complete one lap? Not seconds, not minutes, not hours. 71 days. Let that sink in. Light conquers our entire planet in a fraction of a heartbeat. But to circle Phoenix A star just once, moving at the absolute cosmic speed limit, takes over 2 months. This isn't just big, this transcends big. This is a scale that breaks human intuition. Which brings us to the question that haunts every astrophysicist. How is this even possible? According to everything we know about physics, Phoenix A star shouldn't exist. Black holes form when massive stars die and collapse. Then they grow by consuming matter. But there's a limit, the Eddington limit. If a black hole feeds too aggressively, the radiation from its meal pushes away more food. It chokes on its own power. Given the speed limit, there simply hasn't been enough time since the Big Bang for Phoenix A star to grow this large. The universe is only 13.8 billion years old. Phoenix A star would need several times that long to reach its current mass through normal feeding. So what's the answer? Scientists have proposed something terrifying, the direct collapse theory. In the first moments after the Big Bang, before stars even existed, massive primordial gas clouds didn't fragment into smaller pieces. Instead, entire clouds, millions or billions of times the mass of our sun, collapsed instantly under their own crushing gravity. No star phase, no gradual growth, just an instantaneous birth of a supermassive seed. Phoenix A star didn't grow into a monster, it was born one. For billions of years, it's been feeding relentlessly. Stars by the thousands, entire solar systems, other black holes. Everything that comes close enough gets ripped apart and consumed. And with each meal, it grows stronger, heavier, more unstoppable. But here's the paradox. How do we see something that's completely black, 5.8 billion light years away, hidden in absolute darkness? We don't see the black hole itself, we see what it destroys. When Phoenix A star feeds, it becomes one of the brightest phenomena in the entire universe. The Chandra X-ray Observatory detected something shocking. Enormous voids in the surrounding galaxy cluster, carved out by jets of energy blasting from the black hole at nearly the speed of light. These jets pushed away gas clouds weighing trillions of solar masses, creating empty cavities the size of entire galaxies. By measuring these voids, we calculated the power of the engine at the center, and the numbers were incomprehensible. Phoenix A star doesn't just consume matter, it shapes the structure of space-time itself on scales we're only beginning to understand. Everything ends, even monsters like this, but the death of Phoenix A star lies so far in the future that calling it distant is meaningless. Through Hawking radiation, black holes slowly evaporate, releasing their energy back into the universe. But Phoenix A star is so massive that this process will take not millions of years, not trillions, but a Google years. That's a 1 followed by 100 zeros. A number so large, it's essentially meaningless to human minds. Long after the last star has died, long after the universe has gone completely dark and cold, long after even atoms have decayed into nothingness, Phoenix A star will still exist, a silent monument to power, a fortress of warped space-time floating in an empty, dead cosmos. And somewhere in that unimaginable future, it too will finally fade, the last whisper of the universe that once was. We've journeyed from Earth to the edge of comprehension. What we found isn't just a black hole, it's proof that the universe can create things beyond our capacity to imagine. Phoenix A star stands at the absolute limit of mass, power, and time itself, and it's out there right now, wailing in the darkness, feeding, growing, an engine of destruction so vast that our entire existence, our planet, our sun, our solar system, wouldn't even register as a snack. Welcome to the universe at its most extreme. This is Phoenix A star, and nothing will ever be the same.